Greetings and welcome to my channel. My name is John Gabriel. So today I'm going to talk about an article that was recommended in my academia feed to show you how clueless mainstream mathematics academics are, and in fact to illustrate some of the very common errors they make when they try to teach mathematics. Now, the article I'm referring to is one by somebody called David Toll and called Inconsistencies in the Learning of Calculus and Analysis. Unfortunately, this fool has been a math lecturer. Very, very sad. But anyway, let's see what he has to say. So, the first irony is that this paper actually doesn't discuss anything in calculus. Just to get that straight, it says nothing about calculus, only about functions, convergence, and limit theory, which are not calculus, by the way. Then it says, I first became involved in the difficulties of students learning the calculus and analysis. Well, actually, calculus and analysis are generally the same thing, so it isn't right to say learning the calculus and analysis. And so his English is pretty bad as well. His grammar is bad. His ability to express himself is pitiful. And he's one very confused poster boy of mainstream mathematics. So the first thing he comes up with is the definition of the limit. And he botches this up pretty badly because he resorts to something known as Euler's blunder, which is the decree that S is equal to lim S is valid. It's not, okay? And the reason it's not valid, if we ask my smart GPT to analyze this, it tells you why that's not valid. It says the blind acceptance of this identity conceals a category error, okay? In other words, the left side is a limit, a completed form, while the right side is a formal series. This is a formal series, a generating expression, not a value, okay? So this identification equates an object with its process, and what's more, it's a non-terminating process, a conflation that poisons all modern analysis. Okay, so that's his first error. And of course, the Eulerian decree is in Euler's Elements of Algebra, where he says, Daher ist uns Bruch, this guy here, gleich dieser unendliche Reicher, this guy here. So evidently, this here is a limit and this here is a series. Okay, two different objects. This is why it's also absurd to define a number as an infinite decimal expansion. The very thing is mental rot in the brains of mainstream math academics with zero aptitude for mathematics. Just to give you another example where David Toll makes a big boo-boo, he says, a week later the students were asked to write down various decimals as fractions. He didn't write down this left part here, quarter, 1/20th. He just wrote down this. He wrote it down wrong because I think he wanted to write down that the attempt is to write the fractions as base 10 expansions. So he doesn't pay attention to detail, to grammar, or even context. Now, if we go back to his drivel, this article here, um, he lists some examples which show that he's not reflecting what students think. Excuse me, he's reflecting the confusion in his mind and his fellow lecturers, okay? And they're one very confused lot. So he says that 16 to 17-year-olds perceive recurring decimals, say 16 to 17-year-olds see recurring decimals as dynamic, not static entities that are not proper numbers. Well, recurring decimals are not proper numbers. Okay? Because they don't stand for numbers. They're shorthand for series. Okay? They're shorthand for series. Similar attitudes exist towards infinitesimals. I mean, infinitesimals are just such garbage that I won't even discuss them. But he carries on and he says that cognitive conflict associated with limits of sequences, functions, and continuity is considered in Toll and Vinner. That's one of the publications that he wrote. Okay. And he says the phenomena are here interpreted in terms of the theory of concept image and concept definition. What a load of crap. And in any case, so he says, we shall use the term concept image to describe the total cognitive structure. So now he's into brain psychology and analysis. And obviously, these are things that are so dependent on many factors and so iffy that it's really not even in his place to discuss these things because he doesn't know anything about the brain or how it works. And then he says, on the other hand, the concept definition is a form of words used to specify that concept. Then he comes up with another example. Now, I want to just focus a little bit on this example. Which of the following functions are continuous? Well, first of all, in the first one, he doesn't even give an interval. He just has a parabola. Okay, and so when you look at that parabola, you would say it's continuous, right? But it doesn't show the entire parabola. So theoretically speaking, even f1 is not continuous because that diagram is not the parabola. It would go on forever, right? And there's no such thing as forever. So it has to be stated over an interval. So that's the first big mistake. The second one, he says that f2 is continuous. He actually says that this is continuous when it's actually undefined at this point. Okay. And of course, it's asymptotic to the axis. Well, it's actually not continuous because it's undefined at x is equal to 0. Saying x is not equal to 0 doesn't make it continuous. But he thinks it is, and so do his fellow idiots. And then, of course, he says f3 is continuous, but f3 is not a function. It's a drivel concept called piecewise function, where there are two different rules. Okay, you can't apply calculus to anything that has more than one rule. For example, if you try to find the area under this curve here, you'd have to work with the two sides separately because the fundamental theorem doesn't apply to piecewise functions. Stop. The fundamental theorem does not apply to piecewise functions, you fucking morons. It applies to one rule. Okay? And he does the same mistake here with F4 and F5. Okay? So, totally confused. Now, none of this has anything to do with calculus, by the way. This isn't calculus. This is a big waste of time for students who begin to study calculus. It's not, it doesn't, it doesn't help you one iota to understand differentiation or integration or anything that is worthwhile and valuable in calculus. Because you know what? Calculus needs to have a smooth function. So if your function is not smooth, like this parabola, or this side of the function here, or this side, you can't use calculus. You can toss the methods of calculus out the window. So he says that f1, f2, and f3 are continuous. So he says that these first three are continuous. So this one, f3, is also not strictly speaking continuous because it consists of two separate functions. Okay. In other words, it's a garbage concept called piecewise function. And the reason they introduced this early on in the theory is that they needed it for their limit crap, because the limit crap needs to be able to have a hole at the point of tangency. Of course, they don't understand tangents. That's the next thing that we get to. So, you know, um, this guy here says that one of the students said, uh, meanwhile, one student considered the statement false. This statement here that as B approaches A, the line through AB tends to the tangent AT, because for the sensible reason that the lines were infinite. Way off, so that the lines were infinite. So way off at infinity, the line AB and tangent AT was still a long way apart, no matter how close A and B became. Can you see what utter syphilis these mainstream academics have in their brains? And if you don't believe me, come to this site here where Paul has his online notes and see how he battles to define a tangent line, by the way, and how he battles even with the concept of parallelism. This is a nice red flag here. We've used the word parallel a couple of times now, and we should probably be a little careful with it. Mainstream academics are such cranks. It's almost, I'm almost at the point of just rolling on the floor laughing. So he goes through some other reasons and then quotes more of himself and more of his mainstream colleague idiots. Totally clueless, by the way. Nothing to do with calculus. The guy's a moron. Now, a third cannot equal to 0.3333. Okay. Why? Because a third is not measurable in base 10. And you cannot turn around and say, oh, but this theorem that I proved to you in this article only applies to a finite representation. Nope. It applies to any representation of a third in base 10. It's impossible for you to say that it's impossible for 0.333 dot 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 to be a measure of a third in base 10. Can't be done. No way it can be done. Okay. There is no fraction in the form of p over 10 to the n that is equal to one third. But of course, these simple facts are hand waved with the bullshit of limits and the Eulerian decree S is equal to lim S, etc. Now, listen, I do know better than you and all your moronic lecturers on the planet put together. They're all incorrigibly stupid imbeciles who cannot be redeemed. Okay. And they should basically never have been allowed to enter a classroom. Even as a student, they should have had a different vocation, probably janitor of public toilets or something. But I think I've gone on long enough. I'll give you links to these articles so that you can see how confused these people are. And you can learn why you battle with calculus. It's because you have prize apes trying to teach you what they've never understood. Oh, here's another thing that has been floating around in their syphilitic brains. It says, for example, doing geometry of curves only with circles can give a dangerously limited idea of tangent. It's obviously these fucking baboons never heard of Archimedes' spiral and how he squared the circle. And that if he thought of tangent the same way as these apes did, he never would have squared the circle. Okay, if you're not already a subscriber to my channel, become a subscriber. Follow me on academia.edu. Tell your friends about this, tell your teachers, and join my members only channel to get information that I don't normally share with the public. I'm the great John Gabriel. Till next time, goodbye.